Hi, my name is Samantha Munoz and my partner is Andrew Linehour, and for our project we developed a digital temperature sensor alarm. So to begin, I will talk about each component included in this project and then move on to the overall circuit. First, we have a TMP05, which is a digital temperature sensor, and on the following slide, we will find a layout of the pin diagram for this component. As seen on this TMP05 pin diagram, there are 5 pins for this digital temperature sensor. One which is a out pin, another one which is the converting or input pin, which is where the sensor was connected, a functional pin, and then a VDD, which is the voltage input, and then a ground pin. Following the pin diagram, we have a circuit diagram from the datasheet for the TMP05 that depicts the overall function, the overall setup of a usual circuit, including this digital temperature sensor. This diagram of the TMP05 shows how the input, VDD, output, function, and ground pin should all be connected in a normal circuit, along with the inward workings and functionality of the actual TMP05. The next component used in the digital temperature sensor alarm circuit is a simple buzzer that takes an input voltage to activate a sound. The next component used in the digital temperature sensor alarm circuit were 2 LEDs, one that is red and one is green, which also just takes a simple input voltage to activate it. These LEDs were chosen in order for there to be a simple way to display to the user whether the temperature is high, which is above the threshold of 20 degrees Celsius, or low, which is below the threshold of 20 degrees Celsius. The red LED was used for the high path, the green LED was used for the safe low temperature path. The final component used in this circuit is the LCD display, which takes the reading of the value temperature from the digital temperature sensor TMP05 and displays it on a screen for the user to read. This picture displays the table for the LCD display that describes which pin numbers equate which inputs and which outputs for the LCD. In this picture, we can see the constructed circuit where we can see the TMP05 connected to the buzzer, the red and green LEDs through output pins, along with the LCD display, which these were all connected to the microcontroller, which is also connected to a voltage input-output along with ground. Next, we will get into the code, the flowcharts, and the circuit schematic. This slide shows the top circuit schematic for this digital temperature sensor alarm circuit. So as seen, we can see the TMP05 connected to a clock along with an input sensor which will read the actual temperature. We can also see the output pins for both the red LED, green LED, and then also the buzzer, which has its own output pin to activate. Also on this screenshot is the UART, which will display a similar message to the LCD, which we can also see on this circuit schematic. One major key in this circuit schematic is that there is no ADC present, and that is due to the TMP05 having a built-in ADC converter which converts the analog input to the digital output, and that is one of the main reasons that we chose this as a component. And another main reason is that the PSOC creator actually has a TMP05 component built into its code, so it made it a lot simpler and a lot more efficient to use that exact digital temperature sensor so that there was no extra op-amp or PWMs or ADCs necessary. On this slide, we have the pin diagram that shows all of the necessary input-output pins along with the TMP05 sensor and the LCD display connected as seen. This screenshot shows the beginning of the main C code, which shows the temperature variable being initiated, along with the starting of the LCD, UART, and TMP05, which is necessary in order to continue on to the for loop and the if statements that will be discussed next. In this slide, the code continues with a for loop followed by the definition of the temp variable, along with the TMP05 get temperature function. This function allows the TMP05 to begin sensing the temperature in the surrounding air and begin recording that data. Following this function is the if statement for the temperature being above or equal to 20 degrees Celsius. Within this if statement, we have the LCD position along with the custom message for the print strings, along with the activation of the red LED and the UART print string as well. The code then continues to be the if statement for the low path, which is the temperature under 20 degrees Celsius, and this if statement is almost identical, other than the fact of there being a different message for the LCD, the UART, and also it being a green LED instead of a red LED. This slide depicts the overall flowchart for the main C code that shows the general processes and the general inputs and outputs for the circuit. This slide shows the more specific flowchart for the for loop, which includes the if statements for both the high path and the low path.